Wait, so I just checked. I think the VOD contains everything from where I start the OBS like streaming rather than this. But I wonder what the stream actually has. And it's not like a huge streamer where my chat like immediately goes, so I can't really check. But that would be interesting to know. Hello, someone who joined. Let's start with popping out chat and moving it to here. Yeah. Then doing the same thing for VS Code. Hello, Big Cat. Hello, Mood. First of all, I want to share something that I just did. It's very, very personal, but I think that's kind of interesting. So, there are a few commands in VS Code that I have been using for a really long time. Let me toggle screencast mode so you can see what I'm pressing. So the first command is go to editor by typing its name in. Then go to the editor that is opened by their recency. Then we have breadcrumbs, and what else? Oh, and I guess this. So the first three that I mentioned, they used to be on like fairly easily reachable characters for me, or other hotkeys, but not perfect. So by default, you press Control P to open this thing. Then for breadcrumbs, I don't even know if there is a built-in hotkey, but basically I had it on Control Shift P, which is like pressable, but not so easily pressable where it's any reasonable to use this often or at all. And the third thing, this doesn't even have a hotkey by default. You would usually press Control P to get here and then type in EDT AMRU, but you can set a hotkey to it as well. And I had it on Alt single quote, but I moved them, as you may see, on Alt J, Alt K, and Alt semicolon. And also have go to symbol, which used to be on Alt P, now it's on Alt L. The reason behind this change is I'm a touch typist, so Control Shift P default is open command palette. Yeah, that I redid to Shift Alt P because that's easier for me to press. But I was more asking, like, was the default for breadcrumbs? It might not have one, to be fair. Well, so yeah, since my hands are already on the JKL semicolon keys, it's way easier for me to just press Alt and access those things rather than actually moving my hand, not only my fingers but my hand too, when I have to go to the row at the top to do those commands. Now I don't have to, so I really quite like the change. I don't know, probably doesn't have one. Yeah, probably. I really like this change because even though I'm like incredibly used to the hotkeys that I used to use before, I severely underused something like breadcrumbs when actually it can be useful, but I just didn't really use it because it wasn't that easy to press. Now I feel like that's not going to be as much of an issue. I also moved insert snippet on Alt semicolon and some other stuff as well, I think, where it's going to be nice to use overall. So it used to be Control Space that toggled the suggestion window. Now it's Alt single quote, as you can see, which doesn't seem too reasonable. Hey Archer, we're going to be getting to the Bible very soon. So yeah, Alt single quote doesn't seem very reasonable, but it's easier to press and to reach than Control Space. And plus, you can probably hear this, when you press a space, that's a whole ass key that you can very easily notice. with something like alt single quote, it's way like, it's not as pressurized, if I can use that word. So yeah. Yeah, looking at rustaceans, they're pretty much a cult. They even have like special words for everything, like rustaceans. The Rust programming language book, they literally call the book. I'm pretty sure, like, that's no joke. They literally called the book without specifying it, which is, that's so cultish. And I'm going to be part of that cult. So let's go here. Who is calling me? It's probably a bank that wants to misgender me again. Fuck them. Like, I remember there was a time in my life where I really wanted... Oh, see? I tried to go to the file by the hotkey that I'm so used to. By the way, I was going to tell you this before stream. When you get access to the new usernames, you get a yellow bar at the top. Huh. That's cool, I guess. Huh. Would you look at that? Oh, and by the way, another change that I made, I renamed my channel to not just Axel Fulber, but she, her, because people keep calling me sir, and that infuriates me. Not enough, so I would like delete the older videos where it's not obvious. I think my older videos are still very useful, but I want to give people as much of a sign to know that please stop using gendered pronouns and words with me. I beg you. There's no like gun to your head saying you have to say sir. Why are you so respectful anyway? I'm just a YouTuber. Yeah, so let's go to regl and open the link by typing GL, which is not going to work for you, but I think in VS Code, yeah, I use the VS Code command. Open a link, yeah, you can, right, so you can run the command open link to open the link at your cursor in VS Code, in case you didn't know. Because usually you would control click it, or for me it's alt click, but you don't have to click. There's a command, to which you can even set a hotkey if you want to. I say man, dude, and brother a lot. I mean, yeah, I've heard like a lot of the, I guess, not even take, just what people are used to, using those words in a non-gendered way. But I think a lot of trans people would agree with me that even though you realize and understand that that person is not trying to misgender you, you still view, or rather hear those words as gendered, so it doesn't feel good. So when you're with trans girls, if you can manage to, or at least like to the point of your ability, try to use those words less. I think it's like a bit over the top for someone to react like a dragon if you use that word once without intention to misgender. Like, I'm fine overall, but try to if you can. That's my take. The book is kind of like RTFM for Arch, both really deep cults. Yep. And I'm gonna join the Arch Club too, eventually. So my current idea is to learn Rust, and once I Miss Axel Fulber, Miss 07. The thing is, we're not on Twitch, and I'm not as much of a Twitch viewer, so I don't even know what 07 equates to. What was I on? Right, so once I rewrite my entire project that I have another hotkey into Rust so it can work on Linux, that's when I will fully move into Linux, because there will be nothing still holding me on. Yeah, I know, talking with some RL, they agree almost fully with you. Yeah, that's what I thought. I think the image of the angry trans person is ingrained into a lot of people's minds, in my opinion, because of like right-wing propaganda, where a lot of people expect, I guess, trans people to react like violently and very emotionally at the smallest sign of something that doesn't please them. It's not the case. We're people when we also understand that other people are also people. Yeah. Great wording, Elisa. Yeah, like, we'll understand, but still, like, we may feel a little bad. So, yeah. Oh, and now ampersand, kind of like someone saluting. Oh, I see. I think I've seen it then, but I can't quite picture it in my mind, you know? Yeah, and specifically lowercase o, 7. Okay, thank you for specifying. So, I did some digging, and wait, hold on. I did some mining off camera. You know how, like, Minecraft YouTubers, or I guess any prolonged game, like, Let's Player does? They say, oh, I did some mining off camera, and they have like a full diamond armor. You're like, come on, why didn't you make it into content? When other people are cis men and women, I guess. Do you mean like... Well, if a trans girl is using gendered words towards me, I will be far more mad because, girl, you're supposed to know better. The same way that if a trans girl misgenders someone, like, what are you doing? You're like the master of this entire shit. Why are you like that? When a cis person, like, I'll come with more, I guess, understanding because they're cis, and usually people try their best but are unknowledgeable or unused. Please skip schizo posting cool Rust stuff in my DMs. Convince me to learn it. Well, that's what I hope this stream will do for a lot of people. Schizo to schizo communication. That's outro. Yeah, so I did some reading off camera, not because I didn't want to stream it, but simply because I didn't have the voice to be able to do that. My voice got tired and I just didn't have more to speak inside of me. But maybe, and probably, the more I stream, the more I talk, I'll be able to figure out how to use less and less strain on my voice so I can talk for longer and longer. And then eventually fucking 12-hour streams, I don't know. Maybe not. Depends on how much free time I have, or rather, free time that I could turn into content. There are some things that I have to do that I can't really. Sometimes I don't have the energy to either. So, let's start reading. Handling multiple conditions with else if. You can use multiple conditions by combining if and else in an else if expression. For example, also, one thing that I really like about Rust is that you don't have to wrap the condition in brackets. So after you have an if, there is a guarantee that the next, like, curly bracket that starts a block, so after the if, but before the next block, that's when your condition is going to be. So some languages requiring you to use brackets around the condition, I don't really understand it. Like, surely you can parse it. Why do I have to do that? However, recently I found out how this can actually be good, like having brackets around the condition. Because if we go to Vim and we do if condition something, right? So how do I change this condition? I have to go here. Okay, that's the case for every single thing. And then, well, imagine that I'm like indented and I didn't quite go to the start of the line. So now I have to go to the start of the line and then go to the next word. And this condition will often not be a single word, so it's like annoying. But if it was in brackets, what I have to do is just go to the line and then change inside brackets, and I can change the condition. So that's the argument towards actually using brackets. Yeah, Rust learning stream will be super cool. Well, yeah. Like a Rust book read along? Yeah, pretty much. So, no boilerplate, who I mention in the title of the stream, and going to continue until he shows up, or until I am done with Rust, or either learning it. In his video on how to learn Rust, he says, first of all, run the whole book, read the whole book, but don't go into detail if you don't understand something. That's okay. Your idea right now is to collect all of the things that you're supposed to know, so you can more easily reference them once you see them in some other place. And then once you're done reading the book for the first time, you can read it a second time. Let's go to Regel. So this is what this link is for. This is the cooler, I guess, version of the book that has more interactive questions to help you learn better. So that is going to be the second read. And at the same time, I will install Rustlings, which is essentially a bunch of exercises for Rust that I'm going to be going through along with this book, so on the second read. As well as, I guess, that I'll read someday, and Rust by example I'll also be going through on the second read once again. And this is just something that I saved, it doesn't really matter here. Does Rust have a switch statement? Yes, it's called a match statement. Or do you just use a dictionary? I feel like I'm the type of person who will still use a dictionary, but no, it does have a switch statement, which is called the match statement. And I think it's been shown prior, but maybe it wasn't on stream because it could be in the section that I read offline. We'll see, I guess. So yeah, immediately I want to go on a tangent and say, oh, this is actually bad code. It's so hard to read, but it's so small scale that it shouldn't really be, like, I shouldn't complain about it. Like, it's not a big deal. However, true, I would use at the very least a match statement here. And I also remember by watching Tom Scott's video on FizzBuzz that this is, well, this is kind of like FizzBuzz, almost. I know the better solution to FizzBuzz, and it's by concatenating a single string rather than an else if arm branch, whatever. So I wouldn't even use this. The program has 4 possible paths it can take. After running it, you should see the following output. Numbers divisible by 3. Great, great, great. Something that I want to figure out, and I guess we will in the future, in C#, .NET Run, .NET runs the project, naturally, so same as cargo run. But in .NET Run, after the word run, you can specify the parameters that you specify into the project. So the args, basically, that are in your main function. I imagine that's the same exact case in Rust, and I imagine you can pass them after run. If that's the case, I love that. When this program executes, it checks each if expression in turn and executes the first body, for which the condition evaluates to true. Notice that even though 6 is divisible by 2, we don't see the output numbers divisible by 2, nor do we see the numbers not divisible by 4, 3, or 2 text from the else block. That's because Rust only executes the block for the first true condition, and once it finds one, it doesn't even check the rest. So yeah, literally how if conditions work in every single language. And if there is a language that works differently, I am so afraid. Using too many else if expressions can clutter your code, as we can see here. So if you need, so if you have more than one, you might want to refactor your code. That is correct. Chapter 6 describes a powerful Rust branching construct called match for these cases. So this switch statement, pretty much, which is even more powerful than a switch statement is in a couple of languages that I've seen. Not just like on a hotkey, but C# too, and some other languages that have a switch. Match is better, like straight up. Using if in a let statement, because if is an expression, that is new. Well, that's interesting, huh? Wow. So that's kinda how you do guard clauses. You don't need, oh wait, no, not guard clauses. The ternary operator. You don't need it because if is an expression. Wow, that's great. We can use it on the right side of a let statement to assign the outcome to a variable, as in listing 3 too. Very much so. A lot of languages have like whack expression rules that don't allow you to have more freedom. I love semicolon languages so much because they are the only like separator. So you can, if you want to, add something else on the same line. You pretty much never want to, but having the ability to is so powerful. I've only seen that in Lua or Lua dialects. I think I've seen it somewhere else, but I can't put my finger on it. Or maybe I'm just straight up lying. Yeah, I'm probably straight up lying. The number variable will be bound to a value based on the outcome of the if expression. Another thing that I have to mention that I've read offline. So this is a statement. If it didn't have the semicolon, it's now an expression, and Rust automatically returns the last expression. This is not an expression, so it doesn't return it. If we remove semicolon, then this is now an expression, and main would return the value of print line, which I imagine is nothing. Yeah. So everything is an expression, unless you end it with a semicolon. But the if statement doesn't immediately break because of this semicolon, because this entire thing is a statement rather than only this. Oh my god, hey Rooney! Fuck yeah, I'm really glad to see you. I'm reading the Rust book. Yes, I'm finally started learning Rust to fully go into the pipeline of what I'm going through. Oh, also, I find it really cute. I know, right? That is just wow. The way that it works is so like simple but effective, and it's not bound to some like overcomplicated way to make expressions. No, it's just this simple thing that you see on every single line, but if you don't, they act in a different way, but in a different way that makes sense, you know? Fuck yeah, you know what's up. Yeah. I'm so like predictable, and I love to be. So first I switch to V2, then I learn Vim, I start using WSL, then turns out I'm trans, then I learn Rust. Like, I will probably at this point become a furry. I would be surprised if I won't. I don't intend to, but I feel like I have no control. Remember that blocks of code evaluate to the last expression in them, as I said, and numbers by themselves are also expressions. In this case, the value of the whole if expression depends on which block of code executes. Huh. You know what I'm interested in? First of all, let's open Rust. You're not immune to Rust propaganda. So true. So true. not only am I not, I'm actually like interested in going deeper into it. The infamous HK Vim trans Linux Rust furry pipeline. Very infamous. Like, oh, come on, like, everyone goes through it, right? It's so funny that we people, if we have some weird thing happen to us, we just automatically assume that that's the case for every single human, when it's not the case. Like, when I didn't realize I was trans, I had thoughts like, God damn, I envy girls so much because their clothes are just straight up better. But I'm sure every man thinks like that. I mean, look at them. Those clothes are better. And it's true that there are cis men who still think that, but this is egg behavior on my part. You stopped at Vim. And I don't mean to call you out like this, but basically, at some point, when I started learning Vim, you were better than me. And then I fucking boosted to the fucking moon. And now I'm like, oh, you can use like this over complicated. Well, I don't think it's complicated, but obscure, I guess. Like Vim combination. And I'm like, Rooney, did you know? And you're like, no. You have a much saner approach to things than I do. I like to find the toy and then become obsessed about it. But yeah, that's like part of me. True. Literally chickened out. I mean, like, yeah, like, if you went further, then you would be trans, and I would accept you for it, but that's, I don't know if that's the scariest part. Then you become an Arch user, then a Rust user, and then the furry, which is that the scariest one? Let's actually look at this. So HK, in terms of how society views each of these things, my guess, or rather my perception of how I've seen it, I think the trans community is more accepted than the furry community. But also, if a person accepts a trans person, they're more likely to accept a furry person. I don't have any basis towards this, but that's what I've seen, I think. I'm borderline insane, and my coding workflow really shows that. So true. I mean, let's remember that, what's his name? The dude who created Temple OS, I forget his name, he was like literally insane. But also he was a genius and created some incredible things. Arguably usable ones, or rather useful, arguably useful ones, but still, some amazing things. And you, Mood, are very similar. Because, as you said, schizo posting, yeah. Basically, often insanity helps you reach... Yes, Terry Davis, thank you. Insanity helps you reach higher heights. Like me in Vim, for example. I can very confidently say that I know more of Vim than the average user. That's like absolutely. But I would also pretty confidently place myself in the top 30% in terms of like skill plus knowledge. Because of my insanity over it, I ended up being better at it. We do still have to recognize that, is that important or useful? You can do just fine just using VS Code, like without Vim. It's not like a requirement. But I benefit from it, so that's why I like it. Let's define a variable. What I want to check is, can I put different types here? I imagine I can't, but I want to know. Let number if suggesting something interesting. If condition. Can I just if true? I guess I can. 5. Wait, do I? I don't. Else a character like C. Where here? Where here? I was using vanilla VS Code for so long, so did I. Yeah. But to be fair, even on vanilla VS Code, I changed like every setting. I had hotkeys for every single thing. So I was very efficient at the default tool, but I did realize that it just wasn't enough, and the breaking point for me was going vertically between lines. So with Vim, say I want to go here, right? With Vim, that's just 5k. Repeat the motion of go up 5 times. And damn, do you have a swear filter? Not me. YouTube, automatically. I checked the blocked words and it's an empty list, but just YouTube decided for me to just ban messages, some of them. And this doesn't matter, apparently. Oh, I guess it does. Yeah, the delay is unfortunately very slow, because when I tried using the different delay, which is somewhere here, well, basically, the short delay takes a lot from my CPU, but the normal delay, which is like 25 seconds, actually lets me stream without sacrificing performance to that extent. So, sorry for that, I don't have good enough hardware to make like faster chat happen. So yeah, interesting. I guess I'll know. YouTube filters a bunch of my chats as well. That's like so annoying, and I haven't found a way to disable that. Like, I want my chat to be able to send links, to say whatever, unless it's like very bad, like slurs, for example. Yeah, that I want to be automatically banned. But yeah, it's doing more than I asked it for. Yeah, so in a usual editor, to go 5 lines up, you will probably either have to press the up key 5 times, or hold it, I guess, which isn't that bad. Not really, but it gets to you. When you spend your entire day editing code, continuing to do this, it stacks up. And to add to that, you actually have to reach to the arrow keys, which are not on the home row, or they're on your main part of the keyboard. So that's like extra bad. And I heard from Toading, by the way, that in NeoVim you can just press 5 something and you just go there. And I was like, wow. So that's when I tried NeoVim, and ever since then I've been loving it. Bold of you to assume I don't press up 5 times even in Vim. Oh my god. That's a crime. I guess you're flexing at this point. If you misuse a tool to this point, I start respecting you again, because that's so ridiculous that you might as well be cool for it, you know? I have to do a fan and on a 60% lol. I actually don't really touch my actual arrow keys anymore. What I use instead is I turn on my Vim mode by pressing Alt space, and then HJKL become the arrow key. So you can see now that it displays as if I'm pressing arrow keys when actually I'm pressing HJKL. So that's another hotkey thing. I imagine I'll be able to replicate it somehow on Linux, or at least I hope so. So I kind of like made a 60 myself. 60s were a mistake, and I don't feel bad for you. Okay, let's look at a 60% keyboard and see if I like it or not. Ooh. Yeah, that's like the perfect keyboard for me. I do still would rather have function keys, and I probably like won't come across a 60% keyboard that has function keys here. It probably makes you press FN with numbers. One thing that I don't like though is how the fuck do you press FN and 0, for example? With the same hand? Fuck no. I would like FN to also be on the left side so I can conveniently press that. So pressing FN somehow and then with the same hand using these arrow keys, fuck, I wouldn't want that. I would not want that. But overall, the idea of a 60% keyboard I do like. So I would get one if it was like perfect. I would get a 60% keyboard with a numpad, which I realize is ridiculous, but oh, and a numpad on the left side. That would be perfect for me. Facts. You made a bad purchase and must suffer the consequences. Rooney, you sound like me with my harshness. Like, oh, if you don't use Vim, you might as well die. That's what I say. And you're sounding way too much like me, and it's not a compliment. It would be on some other case, but not this one. I love it for everything besides coding. I'm surprised. I expected that would be the opposite. Ooh. Well, that's actually great. So, if that is like a hardware change, rather than software that you have to consistently run as a process, then that's amazing. What's your WPM, Alyssa? So, fuck. I'll need to implement that. Disable Alt W on chat. Let's reopen chat. God damn. Did it by accident. Here we go. Yeah, let's check that out. You, Rooney, I envy you, honestly. Like, you started, like, touch typing, and then you just boosted through to, like, 100 WPM, I think, right? When I was practicing for so long, only to reach kinda nothing. So I feel bad because of it. So yeah, let's check it out. But to be fair, I do use harder settings, but they're not so hard where I would have 100 on different settings, you know? Left number pad, yes, because I already move my right hand from the mouse to the right side of the keyboard. I never move my left hand anywhere. Or I guess when I'm vaping or something, right? Or checking my phone. Because by the way, I use my phone with my left hand. So having it on the left side makes more sense because that is one use for the, or rather 2 uses for the left hand and 2 uses for the right hand. Rather than having 3 different places that you have to jump between. So yeah, let's do a quick test. I immediately have an excuse ready for me. I am streaming, so doing a test in this kind of thing will give me worse results than if I did it naturally, but let's see. This. So I guess it's around here on average. I do want to get faster, but no matter how I practiced in the past, it didn't really go on for longer. Maybe because I'm like focusing so much on consistency that I'm scared of going faster and making mistakes, because of which I don't like develop the movements that would let me go faster to begin with. For real, non-Vim users are dead to me. Fuck yeah, you know what's up. Obviously not perfect. Oh, you talking about this? Well, neither is my HK script, yet I'm using it all the time. It's hardware. And HK also has extra functions, so I can move my mouse from a keyboard as well. That's actually amazing. And that's also why I have Vim mode to begin with. With something like a 60% keyboard, I won't have to. My 10 word burst personal best is 190 WPM. God damn. Yeah, I envy that. That's so cool. Bro, I'm still at 20 WPM. You say that, but you'll probably like overcome me kinda soon and make me feel bad too. Just started practicing again today. Good, good. Continue practicing. Okay, I have a deranged take. I think that boys are just faster at touch typing. It's also a misogynistic take, I guess. But that's my excuse. That's why I think I'm so comparatively slow. I think at like 40 WPM you're faster than the majority of people. That's correct. So technically I'm like pretty damn fast. But when I look at like the internet people, everyone seems to be on fucking 100 WPM. Pretty much everyone. And I look at them and I'm like, fuck, why can't I? Surely I practiced more than enough to reach that, no? This is so real though. I know, right? Boys who are terminally online from the start learn touch typing, then never learn normal typing. Lol. Tractor, the reoccurring character on our stream, that start learn touch typing, then never learn normal typing. Yeah, I guess that's the case. Oh fuck, this is maybe like a stretch, but boys who grew up like playing something like CS:GO, and they needed to very quickly type in racial slurs in the chat in CS:GO. Yeah, that's where they like get really fast at typing, I imagine. I was never interested in shooter games or anything of that nature. I played The Binding of Isaac, Terraria, and stuff of that nature. So I like didn't develop it early enough, I guess. Disable numbers and punctuation. Bet you can. I doubt it, but let's try it. I'll probably like words, and sure, I'll pick just English. And I guess also on, yeah. Let's see. Like, I doubt it. I very doubt it. You play Isaac? Yes! I haven't mentioned it to you, really? Well, not anymore. I grew tired of it, unfortunately. But I have like over 1,000 hours in Isaac at least. Used to be a huge Isaac fan, and actually one of the mods that I made for Isaac was the top 1 mod of the week, which, like, I'm so proud of that. Yeah, and at one point I was so good at Isaac that I never took any hits, which is why I got bored of the game and then revisited it much later, when Afterbirth released, I think, or Afterbirth Plus, I don't remember. But yeah, let's do a test then. Fuck, I'm even more like stressed now. Oh. Oh. Thank you, Rooney. You're making me feel good then. Oh, wow. Oh, huh. It mattered that much? I'm surprised. Oh, wow. Okay, so I'm not that bad, huh? Thank you. Well, I destroyed my hands playing shooters. Now I have carpal tunnel every once in a while. Yeah. A male friend that I had like when I was a kid tried like showing me and introducing me into these shooter games. I tried them out and played them for like a bit, but I didn't really stick around. Never really was my thing. But yeah, turns out I'm actually not that slow. Not as slow as I thought. So, especially if I'm on like Discord, which I thought was opened, but I guess it isn't. Why would it? Yeah, if I'm like trying to type really fast, I imagine I'm over 100 WPM. I just was underestimating myself this entire time. Can you die, please? Thank you. Right, so, to come back to this thing, I think it's just going to be easier to catch. If and else have incompatible types. Okay, that's exactly what I expected. So the first one that you specify is the one that the Rust compiler expects, so you can't choose a different type. That is exactly the behavior that I expected. Just wanted to make sure. I also love this. Let's actually run this to see. Expected type did not match the received type. Erroneous code examples. Wow, is that a real word? Erroneous? God damn. Huh, wait, hold up. Oh, calling. Yeah, I thought this function itself was incorrect. And also what's cool is that the explain thing is automatically shown in a pager, in a less window, which I love a lot. Yeah, so found string slice, which I'm yet to learn, but we will. But yeah, that's pretty cool, and it's being explained. That's so cool. Okay, let's continue. The number variable will be bound. Yes, we read this. Remember that blocks of code evaluate to the last expression in them. Yeah, as I explained earlier in the stream, and numbers by themselves are also expressions. In this case, the value of the whole if expression depends on which block of code executes. This means the values that have the potential to be results from each arm of the if must be the same type. It's like there have already been multiple situations. Oh, by the way, live chat, because some things are destroyed for some reason. Right. There have been already a couple of times where I check and figure out a thing only to have it explained in like the next sentence. And that's like funny. Yeah, and I actually just saw it. When we try to compile this code, we'll get an error if the if and else arms have value types that are incompatible, and Rust indicates exactly where to find the problem in the program, which is so nice. Yeah, it's quite the contrived and asinine word, requiring large amounts of premonition to know, lest you feign some Lovecraftian hyperbole instead. But that's just emblematic of an abject state. I want to pin this somehow, but oh, I can. Oh my god, I love that. Oh, that's brilliant. That is just bullying. It is. Even with my pretty good understanding of English, I don't know some of these words. Because if some person, usually a man, uh, like uses that sentence unironically, that's just straight up a red flag. Matter of fact, today a guy texted me on Telegram trying to like get acquainted with me, I guess. He was that type of guy, like very, I guess, stuck up. It's probably not the correct word, really, but he felt like this, and I immediately became disinterested. Even though, like, I'm a trans girl, just saying, yo, girl, that ass fat is already enough to get me interested. Like, I'm not even lying. Like, yeah. But when I see something like this, like, unironically, yeah. Hyperbole. Oh my god, that's the thing. This is just straight up a redditor. True. And often, maybe like I'm too misandric, but when I notice this, I've never noticed it from a woman. Pretty much always a man, or at least that's extrapolated more. Yeah, the people who talk like that often see themselves as smart, when being smart is often recognizing that the more smart you sound, the dumber you made the explanation. That's the basis you at least should be making, and that's what I try to do in my tutorials, for example. If I just sound smart and give the most correct and precise explanation, it's not going to be a good explanation. It's going to be a precise one. Very different thing. So no, talking like that is not smart at all. Talking, to begin with, is a way to exchange information. And this is just not an effective way to do that. Yeah. I speak like this every time my brain rot clears. No markdown. That's unfortunate. But I guess, maybe on Twitch there is markdown, but I doubt it though. Did I just escape a sad face on auto? Oh my god, now it's like angry, but I think it fits more. Does it not? But damn. You know what? That's crazy. There is like a traffic jam outside of my window. I live in such a small city that you basically never see them. So it's like surprising. It does, I know, right? Alright, let's continue. The expression in the if block evaluates to an integer, and the expression in the else block evaluates to a string. Slice, technically. But, yeah. It doesn't... Oh, right! Perfect example of what I just did. I specified it's not just a string, it's a string slice, because Rust has two types of strings in it. Don't worry, we haven't reached that point in the book, I just know it. That's the case. So it could be more precise and say evaluates to a string slice, but it doesn't need to because it's not a good explanation. A better explanation in this specific situation is to say that this is not an integer, this is a string instead, and only specify which type of string when that actually matters. I learned what city you're in, and the Wikipedia article for it has a crazy fact. I'll tell you actually, like, I'll easily dox myself. I live in Angarsk, and if there's anyone who would somehow come and meet me, I would be impressed enough where, like, sure. Yeah, so our city has my pride. Basically, we had like one of the biggest serial killers in Russia from this city. Yes, that's what we have to be proud of. Nothing else, really. And to be fair, I do think it's kind of cool. Like, yeah, I understand. The people died and they suffered. Okay, but like, our town, this shitty little city that barely exists, has such an affecting figure, you know? Yeah, I love that about strong typed, I guess, languages. You can know for sure a lot of things, and that is very nice. Knowing the type of number lets the compiler verify the type is valid everywhere we use number. Rust wouldn't be able to do that if the type of number was only determined at runtime. The compiler would be more complex and would make fewer guarantees about the code if it had to keep track of multiple hypothetical types for any variable. I love the fact that it actually explains why it's being done that way. Because people who are coming from dynamic typed languages would be like, oh, god damn, that's so annoying. But explaining why that's the case actually makes it more valid in the minds of those people. And like, I'm not special, I was also in them, but like, I ended up realizing why this is the case and why it's beneficial. Ain't no such thing as bad press. True. The delay is crazy. I say something and it takes 3 business days for a message to arrive. Good job! What's most like incredible and impressive is the accuracy. Because when you start out, you look at your WPM and you might be like, oh goddamn, all these people are faster than me. But the accuracy is what really helps you. So good job on both of those stats. Continue practicing, and you will overtake me, like, because you're a boy. Yeah, so I'm gonna continue this fucking stupid rumor that is based in nothing. Yeah, so focusing on accuracy will give you consistency and trust in whatever you're typing in. Why is there an error? Expected because of this. Because of what? Because of what? So there is a linter. Because of what? That's so strange. Yeah, basically, if you have very high accuracy, maybe you're not that fast, but you can be sure that any key that you press is actually the correct key. And I think that's way more valuable than being faster, but not having that surety. For this task, Rust provides several loops, which I actually find really cool. Instead of using while true, what you can do is just loop. And I love this so much. And now I also wonder, let's just check if this is true. No? Okay, fair enough. But yeah, this is an infinite loop, and it's, I think, more readable because loop this. And you don't specify anything, meaning that, yeah, it's an infinite loop. Then the mental gymnastics, which, to be fair, every single programmer more or less already understands. The mental gymnastics of while true. I think a loop is more like readable than while true, you know? Which will run through the code inside the loop body to the end and then start immediately back at the beginning. To experiment with loops, let's make a new project called loops. About projects, I'm going to be making all of them and doing all the exercises myself on the second read of the book, when I'm actually going to be like doing exercises. Rust has 3 kinds of loops: loop, while, and for. Let's try each one. It doesn't have a for each. It probably does, but it's being done in a different way, I can only imagine. The loop keyword tells Rust to execute a block of code over and over again forever, or until you explicitly tell it to stop. As an example, change this file in your loops directory to look like this. This will continue on until you press Ctrl C. Well, I imagine. I imagine that's the case. I would be surprised if not. When we run this program, we'll see, again, printed over and over again, continuously until we stop the program manually. Most terminals support the keyboard shortcut Ctrl-C, as I said, to interrupt a program that is stuck in a continual loop. Give it a try. Imagine if that wasn't the case. If you're just like stuck forever. Reboot. Like, that would be funny. The simple Ctrl-C represents where you press Ctrl-C. You may or may not see the word again printed after the Ctrl-C, depending on where the code was in the loop when it received the interrupt signal. That's interesting. And it makes a lot of sense. I just, like, it's so fast that I wouldn't expect it to matter, but also obviously it does, right? That's interesting. Fortunately, Rust also provides a way to break out of the loop using code. Imagine if it didn't. You can place the break keyword within the loop to tell the program when to stop executing the loop. Sam Energy as turning off computer to get out of Vim mode. Oh, same energy. Oh, I see. True. These like, oh, I don't know how to quit Vim memes. They're funny at first, but then they get so old. Because no, I feel like even if you're a beginner, you've seen enough reposts on programming humor, the subreddit, where you do know how to exit out of Vim. Even if you don't use it, or even if you don't intend to use it, you probably know. More than some other situation that is actually going to be less Googleable. Oh, how do I get out of Vim? You probably already know, and if you don't, very easy Google search away. Rather than how to set up this mega specific thing that only ChatGPT for some reason can help me do. Recall that we did this in the guessing game in the previous chapter to exit the program when the user won the game by guessing the correct number. We also use continue in the guessing game, which in a loop tells the program to skip over any remaining code in this iteration of the loop and go to the next iteration. So far, most of Rust is either the same as in other languages, or understandable, like very much so. Some things are way different, but for the most part, like, yeah, break, continue, all of this, I already know. Problem with that sub is that the meme is funnier the more niche it is, but niche memes don't get upvotes. True. Very, very true. And finding that mega niche meme is just so valuable. But I guess that's kind of on me for sorting by best. But at the same time, if I sorted by new, I would get even shittier posts in my feed, which I don't necessarily want. So yeah, my point on this is that so far Rust is not that scary and like understandable. Returning values from loops. One of the uses of a loop is to retry an operation you know might fail. Such as checking whether a thread has completed its job. You might also need to pass the result of that operation out of the loop to the rest of your code. That's actually very interesting, because I do wonder how you do it. Because shadowing won't work. By the way, shadowing. So let's define a variable x, which will have the value of something. Yeah, and then we can let x again something else. So variables in Rust are immutable by default, and I hate when people just say, oh, immutable, and just go on. Immutable was one of the most fucking obscure words I have ever heard before I actually understood what it meant. Immutable means it can't be changed, can't be mutated, you could say. So you can't do something like this, because the x, this variable, is immutable, which turns out just means you can't change it after you declare it. So why can we do this? Because of shadowing. In Rust, you can define a new variable with the same exact name, and it's going to be a new variable. We're not redefining x. X is still guaranteed to be immutable. We're actually creating a new variable with the same name. And this technique is called shadowing, because you're kind of like shadowing the old variable with a new variable. And actually, let me give you an example. So here I just created a new block, and let's print line x. And instead of this, we will also press x. Okay, let's .NET run. I'm not C-sharping. I am not C-sharping. Let's car instead. Hold up. Format argument must be a string literal. Isn't shadowing exclusively a scope thing? Surely you're just overwriting the old variable there. Yes, that's exactly what is happening. But what I'm trying to get across is you would expect Rust, because everything is immutable by default, to say, hey, you actually already have this variable, you can't define it again. Which is what would happen in C#, for example. But there, things are mutable by default, or at least most of them. So yeah, you would expect Rust to be annoying, but it's actually not. Where, say you change the x to something else via some method or function, you don't have to do x changed. No, you don't. You can just still call it x. So that's what I'm talking about. So turns out there's something about these, so let's just use different numbers instead to show off what I'm trying to tell you about. What? I guess I don't know how to use readline. Okay, like this. That's what happens when you try to give a quick example, but you don't know the language. Okay, this should work now. And once it builds, 3 and 5. So, this is a new scope, and you can still use the same variable name, and it prints 3 for us, and this x variable is still there, and prints 5. Let's do it this way now, and car again. Three, because of shadowing, so we overrode it. But Rust intelligently noticed that, what the fuck are you doing? Let's go back to the hello world. Yeah, so that's shadowing, and I quite like it. I was trying to figure out, like, what the fuck? Like, why is the linter acting up? That's because it only runs on save, and I no longer have autosave. I save manually, so that's why it acts up when there is no longer an issue. I don't have an issue with that though. I think that's how it is better. No. Really? That's so cool. What the fuck? Hold up. To do this, you can add the value you want returned after the... Wow! Loop is an expression! Loop is an expression! Let's go! You know why this is amazing? Usually, say, like, let me give you a situation that is, like, real. Well, kind of real. In AutoHotkey, you define a new variable called var, which is unset by default, unset, and then you loop until is set var, and here you, I guess, wait for it or something. Basically, there are points where, because the loop is not an expression, you might need to mutate data, but in Rust, because loop is an expression, you don't have to. You can do all of your logic on getting the result immediately without having to mutate this variable later, and that's so nice. I've never seen this in any language, and to be fair, I haven't discovered that many, but this is impressive. That's fucking weird, but okay. Better than setting a variable and breaking. Yeah, at the very least. But since variables are immutable by default, I do like this behavior. Because, yeah, better than setting a variable and breaking. Oh, you were talking about this thing. Oh, I see. Yeah, quite weird, but interesting, because giving more use to keywords, like specifying something to break, because what? Are we going to use return? We're in a function, and since loop is an expression, we need to be able to return out of the loop, not the function. So that's quite interesting. Just figured it out while explaining it. That's how I make my videos, by the way. That's so cool. Pretty stupid example, by the way, because like wouldn't you just like result is 20? But sure, it's just an example. Then we declare a variable named result to hold the value returned from the loop. On every iteration of the loop, we add 1 to the counter variable, then check whether the counter is equal to 10. When it is, we use the break keyword with the value of this after the loop. We use a semicolon to end the statement that assigns the value to result. Finally, we print the value in result, which in this case is 20. I see labels, and I'm immediately scared. Like, oh no, you know? Okay, oh, no. I'm spoiling myself without actually reading. Let's go through it. Loop labels to disambiguate, goddamn, between multiple loops. If you have loops within loops, break and continue apply to the innermost loop at that point. You can optionally specify a loop label on a loop that you can then use with break or continue to specify that those keywords apply to the labeled loop instead of the innermost loop. So, you can specify the label to this loop instead of this loop. It's similar in AutoHotkey where you specify a number. Usually it's just break, but you can break too to break the outermost loop. And I can only imagine that's the same case or a similar case in other languages. I just haven't really had to do that in C#. Loop labels must begin with a single quote. Interesting syntax, that's for sure, but alright. Like, I don't hate it, you know? In my opinion, if you need to use this, you have a structural issue with your code. You mean this? Yeah, I would probably agree on this. Cool that it's a thing. I guess it has labels because you can't do print 2 here. Or break 2. Because break 2 would return 2. And that's why Rust has labels, I guess. But yeah, I don't remember the last time I needed it. Cool that it exists. Good to know. But yeah. Probably don't write your code like this. Nested loops is like questionable to begin with in a lot of situations. Obviously, something like an algorithm will often have nested loops, but a nested loop in a lot of situations is immediately O of n squared, which is like, I didn't know that. Svelte uses them for reactive statements. It's kind of weird. Yeah, that's what JavaScript is, I guess. The outer loop has a label counting up, and it will count up from 0 to 2. Yeah, I've like never used nested loops besides parsing an entire object. And even at that point, you will often use recursion, which is technically just nested loops, but hidden. More readable, but not as understandable. That's how I would describe that. Yes. The inner loop without a label counts down from 10 to 9. The first break that doesn't specify a label will exit the inner loop only. The break counting up statement will exit the outer loop. The code prints this. Interesting? Sure. I just didn't read into the code because this is just an example to show off labels. The code probably doesn't really matter. I see. Side-eye as I look at my most recent HK code. Lol. Side-eye when I look at my old HK code. Let's go to a thing that I am continually wanting to rewrite, but I just can't get to it because I'm not that interested. I used to... Wait, how do I... Like this, okay. I used to write my code in one huge function that then usually had sub-functions using closures, which is like a pretty good approach for a beginner to still make their code better. But with classes, this becomes far less needed. And while this isn't bad, really, just a class for something like this is a better approach. There's the negative, though, the fact that classes don't have private things in other hotkeys. There's just no implementation of that. But with something like this, you can emulate a class that does have private parts. Recently, when I've been learning JavaScript, actually, that's where I got the idea from. The more like functional programming type of thing, where you emulate a class using a function. It's not as pretty, but it does give you a way to make things private, where all the instance, quote-unquote instance, variables, you just like specify this is unset, and then you this when it is an object, you add more stuff like values. I hate this. Like, can you shut up? Like, if you fail once, okay, I get it. Don't continue saying that to me. I misuse closures a lot. They're insanely useful for decorators. I haven't gotten to decorators in anywhere, really. But yeah, closures are really nice to misuse. I wrote one as early as yesterday. Yeah, closures are like really nice to misuse. Just like alcohol. Let's go. I actually used to drink somewhat often. I had cognac in my fridge like permanently, and I drank like from time to time. Not to a point of problem, but like I enjoyed alcohol. But some time ago I just kind of got disinterested in alcohol, so I don't really drink anymore. I'm not gonna say that, oh, I'm a never drinker now. I just am generally not interested. I would rather be sober. Like, if I'm drunk, I can't do programming stuff as efficiently. And that's seriously my point against it, like, because I'm not as efficient. Which shows you a bit of the inside of me, of not letting myself rest enough. Me sitting over here having no idea if closures are even in V1. No, because you can't put a function inside of a function in V1, which I learned once. I was bombazled. I was flabbergasted by that information. Like, what? It's so incredibly surprising, because holy shit, I've been doing that all the time. Conditional loops with while. A program will often need to evaluate a condition within a loop. While a condition is true, the loop runs. When the condition ceases to be true, the program calls break, stopping the loop. It's possible to implement behavior like this using a combination of loop, if, else, and break. You could try that now in a program if you'd like. Yeah, it's interesting that the different types of loops are like the same exact idea, just with syntax sugar. And quick Lua slander, that is maybe even just incorrect, but why I hate Lua is that it only has one type of loop, because technically you can make any type of loop with a while loop, so why add syntax sugar? You don't need it technically. And I hate that Lua only has while loops. As I said, I simply do not know, so I'm probably wrong, and I hope I'm wrong. But that's just a guess on how Lua works, because in other places, Lua often doesn't add features because they can be somehow done in a different way. UA script fixes that. Wait, no way, am I right? I hate Lua because I suck at it. Technically that's yeah, same. Lua requires me to reinvent the wheel instead of just using like something better. I really don't like Lua. I low-key wish that you could put a number after a loop to loop this many times, rather than creating a counter, which is what you would have to do now. You kind of need to have brain rot to learn Lua, yeah, or be a Roblox fan, I guess. I would just rather have a more full-featured language, which I do understand will be more bloated, I guess you could say, but those features are just so nice that being able to use them and focus on the actual problem at hand seems better to me. Aww, that's adorable. This construct eliminates a lot of nesting that would be necessary if you used loop, if, else, and break, and it's clearer. You say that as if guard clauses don't exist, but I do still agree. While a condition evaluates to true, the code runs, otherwise it exits the loop. Looping through a collection with for. A for each loop. That's nice. You can choose to use the while construct to loop over the elements of a collection, such as an array. Wait. We'll get to it, don't worry. For example, the loop in listing 34 prints the each element in the array A. Wait, are you telling me plus plus is not a thing? Is it not? Let mutable count is 0 counts plus plus. That's not a thing? Why? Why? Are you Python or something? Why would you do that? Value assigned to count is never read. Maybe it is overwritten before being read? That sounds like a useful error message. Yeah, I'm surprised. I love that operator so much, so I don't like that it's not there. Here, the code counts up through the elements in the array. It starts at index 0 and then loops until it reaches the final index in the array. That is, when index less than 5 is no longer true. Running this code will print every element in the array. All 5 array values appear in the terminal as expected. Even though index will reach a value of 5 at some point, the loop stops executing before trying to fetch the 6th value from the array. Yes, so how loops work. However, this approach is error-prone. We could cause the program to panic if the index value or test condition is incorrect. For example, if you change the definition of the A array to have 4 elements, but forgot to update the condition to while index is less than 4, technically, we should be using array.length or something of that nature, but okay, it's just an example. A in index in close proximity is PTSD. Oh no. Oh, yeah. Fuck A index, honestly. I never use it. I don't trust it. I don't trust that bitch. Okay, so it's saying a for loop, meaning a for each loop. Can we put for index element? I might want still to have the index to be able to use it. When we run this code, we'll see the same output as in there. More importantly, we're now increased the safety of the code and eliminated the chance of bugs that might result from going beyond the end of the array or not going far enough and missing some items. Using the for loop, you wouldn't need to remember to change any other code if you change the number of values in the array, and you would, as you would with the method used in listing 34. The safety and conciseness of for loops make them the most commonly used loop construct in Rust, or in any language I feel like. Or in a lot of languages. Ah, that's what I thought. Okay. For number in this will print 4 numbers, I imagine. What is rev? Let's just try it out. Let me actually toggle this. let's try it out. So what do we get printed? 1 through 4 inclusively or exclusively? I think inclusively. No. Oh, rev means reverse. Is there like a shortage of characters? Really? Reverse? You couldn't... Oh, I thought it was accepted. Like, come on. You don't need to make it this short. You really don't. But yeah, so for exclusively, I think it's something like this. No, I don't know enough for us to make it inclusive. But yeah, so this is automatically a range, and you, I guess, wrap it in brackets to make it an expression from which you can call the rev method. Okay, yeah. So you don't need a counter. That's very nice. Mm-hmm. This is much nicer than having to implement it yourself every single time for close to no reason. And implementing an abstraction for something this simple is also not really a thing that you do. So having it in the language itself is very nice. You made it! That was a sizable chapter. Was it? I guess. You learned about variables, scalar and compound data types, functions, comments. Ooh, that's going to be a cute program to make. And it's actually a program that I do need, which is the funniest shit. Oh no. Is that gonna be difficult? We'll see. Oh, that's interesting. Ooh, that's so exciting. That is so exciting. We're gonna get to ownership. Understanding ownership. You don't. Period. That'd be hilarious. Ownership in Rust's is Rust's most unique feature and has deep implications for the rest of the language. It enables Rust to make memory safety guarantees without needing a garbage collector, so it's important to understand how ownership works. In this chapter, we'll talk about ownership as well as several related features. Borrowing slices, how Rust lays data out in memory. This is the thing that I never really needed to learn, so getting to it finally is going to be very interesting. Okay, so how long have I been streaming for? 1.5 hours. Yesterday I was able to go for 3, so I wonder if I've gotten better at using my voice or not. I hope yes. So we can go for longer and longer and longer. Ownership is a set of rules that govern how a Rust program manages memory. All programs have to manage the way they use a computer's memory while running. Yeah. Which is interesting that this information is not really known to every single programmer, because I guess most programmers, or a lot of them, don't have to deal with it. They might not even know that this is the case. Some languages have garbage collection that regularly looks for no longer used memory as the program runs. In other languages, the programmer must explicitly allocate and free the memory. Rust uses a third approach. Memory is managed through a system of ownership with a set of rules that the compiler checks. If any of the rules are violated, the program won't compile. None of the features of ownership will slow down your program while it is running. That is just... mwah. Yeah. Or C. I have far more respect for C than I have for C++, by what I've heard about both. Most people who have touched C++ hate it, and like C instead far more. And I really don't want to be touching C++ unless I'm paying, unless I'm being paid for it. Yeah. That's cool. Parts of ownership will be described in relation to the stack. Parts of ownership will be described. Hold on, I got brain rot for some reason. Should stop vaping, I guess. Parts of ownership will be described in relation to the stack and the heap later in this chapter, so here's a brief explanation in preparation. I already kinda understand what those are, maybe not to a good enough extent to please someone like Cloaker. Like, he would probably say, no, actually, you're bad. Yeah. In his style. But I understand the idea behind those and why being on the stack can often be considered an advantage unless it just makes more sense to use the heap. Yeah, it depends, as with anything in programming, but yeah, stack, love it. Heap, also love it for a different reason. Both the stack and the heap are parts of memory available to the code to use at runtime, but they're structured in different ways. Pleasing Cloaker? Wow, Pipe Dream. So true. It's impossible to please that man. He is like, he's an old man. He's supposed to be kinda young. He isn't. In the order it gets them and removes the values in the opposite order. This is referred to last in, first out. Think of a stack of plates. When you add more plates, you put them at the top of the pile, and when you need a plate, you take one off the top. Adding or removing plates from the middle or the bottom wouldn't work as well. Adding data is called pushing onto the stack, and removing data is popping from the stack. I do not know the lore. You maybe get it after spending enough time on the other hotkey Discord server. Or maybe you don't, because you're not like as hyper-focused on Cloaker as I am. I imagined him to be my enemy, and I'm role-playing, mostly with myself. That's what's happening. So that's the lore, more or less. You should try solving Towers of Hanoi. It's an annoying-ass problem. Huh. I might, in the future. Like, once I actually get to using Rust, like once I'm on the second read, I might get to it. Sounds interesting. Where were we? Must have a known fixed size. Data with an unknown size at compile time, or a size that might change, must be stored on the heap instead. Ooh, that's interesting. That part of info I didn't know. The heap is less organized. When you put data on the heap, you request a certain amount of space. The memory allocator finds an empty spot in the heap that is big enough, marks it as being unused, and returns a pointer, which is the address of that location. This process is called allocating on the heap, and is sometimes abbreviated to just allocating. Pushing values onto the stack is not considered allocating. That's interesting to know. Huh. Because the pointer to the heap is a known fixed size, you can store the pointer on the stack, but when you want the actual data, you must follow the pointer. Think of being seated at a restaurant. When you enter, you state the number of people in your group, and the host finds an empty table that fits everyone and leads you there. If someone in your group comes late, they can ask where you've been seated to find you. Pushing to the stack is faster than allocating on the heap because the allocator never has to search for a place to store new data. That location is always at the top of the stack. Comparatively, allocating space on the heap requires more work because the allocator must first find a big enough space to hold the data and then perform bookkeeping to prepare for the next allocation. Makes sense. Accessing data in the heap is slower than accessing data on the stack because you have to follow a pointer to get there. Contemporary processors are faster if they jump around less in memory. Yeah. Continuing the analogy, consider a server at a restaurant taking orders from many tables. It's most efficient to get all the orders at one table before moving on to the next table. Taking an order from table A, then an order from table B, then one from A again, and then one from B again would be a much slower process. By the same token, a processor can do its job better because if it works on data that's close to other data, as it is on a stack, rather than farther away, as it can be on the heap. Yeah. When your code calls a function, the values passed into the function, including potentially pointers to data on the heap, and the function's local variables get pushed onto the stack. When the function is over, those values get popped off the stack. So that's how it works, huh? Keeping track of what parts of code are using what data on the heap, minimizing the amount of duplicate data on the heap, and cleaning up unused data on the heap so you don't run out of space are all problems that ownership addresses. Once you understand ownership, you won't need to think about the stack and heap very often, but knowing that the main purpose of ownership is to manage heap data can help explain why it works the way it does. That's a very good explanation. Like, I feel like even if you're not like learning Rust, just copy pasting this explanation on the stack and heap to explain it to someone sounds very good. Matter of fact, I'm going to do exactly that. I'm gonna copy it. And where was I? It should be in notes. What do I have in notes? Other what files should I use? Tech, sure, tech. And it keeps complaining that, oh, actually, I don't work. Like, why is it consistently saying that? Like, shut up, bro. Stack and the heap. Like, I very obviously don't care. It should only give this error once and then shut up. This is the one really annoying part of the AutoHotkey extension that I hate. Yeah, let's select it until the end and then indent it, not because we have to, but because I want to. Yeah, so now I have this explanation so I can give it to someone. Variable scope. Not that we're past basic Rust syntax, we won't include all the fn main code in examples. Thank you. So if you're following along, make sure to put the following examples inside the main function manually. As a result, our examples will be a bit more concise, letting us focus on the actual details rather than boilerplate code. Thank you for doing that. As a first example of ownership, we'll look at the scope of some variables. A scope is the range within a program for which an item is valid. Take the following variable. Oh, holy shit! So, maybe that's ridiculous to do. I'm not sure yet. But maybe I want to define a variable which is constant by default, not constant, immutable. Constant and immutable are different things in Rust. So let more readable value. So I'm making this variable specifically so it's more readable. And it's like some random number, right? And then I print line this more readable value. We'll figure out how I actually pass that variable. And whether it's, yeah, it's not like this, but we'll figure it out. But basically, after this block is done, this is no longer there. So I wonder if it's like reasonable at all to do that with intent. We'll see, I guess. The variable s refers to a string literal, where the value of the string is hard-coded into the text of our program. The variable is valid from the point at which it's declared until the end of the current scope. Listing for 1 shows a program with comments annotating where the variable s would be valid. Is that not an understandable explanation? I guess it's not really, but basically being more intentional with your blocks. It's a whole level above locals. True. It's like super locals. Well, let me be more precise. In AutoHotkey, locals are just like var in JavaScript, where they're local to the function. In other languages, funnily enough, JavaScript too, if you use let, now that variable is local to the block. So if you create a new variable in an if statement, it will only be available there. So their Rust is similar to like languages like JavaScript and pretty sure C# too. Our previous scopes inherited. Yes. So in this new scope, everything in this scope will also be available here. I mean, if that's not the case, I'll be very much surprised. Pretty much has to be though. S is not valid here, it's not yet declared. Naturally, from this point, do stuff with S, this scope is now over, and S is no longer valid. In other words, there are 2 important points in time here. When S comes into scope, it is valid. Yes, it remains valid until it goes out of scope. At this point, the relationship between scopes and when variables are valid is similar to that in other programming languages. Now we'll build up on top of this understanding by introducing the string type, capital interestingly. The idea is that memory gets freed when control flow goes out of scope, which makes it very memory safe, I think. That idea, yet, is not new at all. That's how garbage collectors work. Yeah. That's how garbage collectors work. The real power behind Rust is the borrowing and all that, and ownership. That's probably where it's the most powerful, because just, oh, did you know that after this block, this variable is no longer there? That is not a new idea. That's how garbage collectors work pretty much. So the cool idea is going to be later when we actually understand what ownership is. We want to look at data that is stored on the heap and explore how Rust knows when to clean up that data, and the string type is a great example. We'll concentrate on the parts of string that relate to ownership. These aspects also apply to other complex data types, whether they are provided by the standard library or created by you. We'll discuss string in more depth in Chapter 8. No worries. I'm also like talking out of my ass. That's what I heard about Rust. I'm not really in a position to be completely sure, but I'm pretty damn sure. But well, I guess we'll see. We'll learn. We've already seen string literals, where a string value is hard-coded into your program. String literals are convenient, but they aren't suitable for every situation in which we may want to use text. One reason is that they're immutable. Another is that not every string value can be known when you write our code. For example, if you want to take user input and store it, for these situations, Rust has a second string type, string. This type manages data allocated on the heap, and as such is able to store an amount of text that is unknown to us at compile time. You can create a string from a string literal using the from function like so. Kinda don't like it, like gonna be honest. The fact that you have to use a whole ass kinda class and method to just make a string, but I guess it's to reiterate that for hard-coded strings you aren't really supposed to be using you should be using the more simple ones, and for something that is supposed to be changed or is of unknown length, that's when you use string. The double colon operator allows us to namespace this particular from function under the string type rather than using some sort of name like string from. Yeah, I like that a lot. There's probably a macro. Yeah, and you can probably make that macro yourself very easily, but I don't like overwriting built-in good practices into bad practices, you know? I don't think there's really a need to do this. It's just something that you should get used to. Just kind of not the hugest fan of it, but I understand why it's that way. This kind of string can be mutated, so we define it as mutable as push string. Appends a literal to a string. Interesting. And then this will print hello world. I see. So, what's the difference here? Why can string be mutated but literals cannot? The difference is in how these two types deal with memory. Memory and allocation. In the case of a string literal, we know the contents of at compile time, so the text is hard-coded directly into the file and executable. Wow, that's interesting. Pretty sure that's not the case in other languages. I remember No Boilerplate mentioning that at first he was like, oh god damn, two string types, what a mistake. But that's actually not my first thought, surprisingly. I like this, like I understand the reason behind it, and I think it's valid. Damn, Rust is like really cool, though I have so much I'm doing with AHK. Same, exactly. Like, boy, look at this. I have 152 HK files doing various things. But it's just not good enough. I mean, no, it's good enough, but something like Rust can help me do even better things because of the help it provides me. I mean, even just types is already amazing. No, Python is the best. Python is like one of the languages that I don't want to touch. It's all over the place. I just don't want to. It's very similar to V1 in the sense that it has a lot of things that you just have to somehow know, or you're not making idiomatic Python code. I guess it's going to be the same for Rust, to be fair, but I was more so making a comparison to V1 and V2, where V2 you can go into more as an overall programmer and just start doing things in a natural way to you, when in V1 you have to know a bunch of edge cases. Python, because it was made to be easy, is all but is everything in edge cases for a normal programmer that is used to a different language. And I just don't want to deal with that. This is why string literals are fast and efficient, but these properties only come from a string literal's immutability. Unfortunately, we can't put a blob of memory into the binary for each piece of text whose size is unknown at compile time and whose size might change while running the program. With the string type, in order to support a mutable, growable piece of text, we need to allocate an amount of memory on the heap unknown at compile time to hold the contents at runtime, right? I guess. This means the memory must be requested from the memory allocator at runtime, literally explains it in the next sentence. We need a way of returning this memory to the allocator when we're done with our string. The first part is done by us. When we call string from, its implementation requests the memory it needs. This is pretty much universal in programming languages. Yeah. Unfounded Python slander. Yeah, I mean, it is, but I've seen a thing after thing, and it reminds me of JavaScript. It's much better than JavaScript, as almost anything is, but still a similar idea. When with something like C#, it may be a bit more annoying at times, but it's far more consistent and understandable, where you don't have to really learn about hyper-specifics of the language to be good at it. Kinda, but not really. So in V1, to be a good AHK user, you have to know like a billion random small things, which might as well be considered bugs. I've heard the same kind of idea about Python. In C#, sure, it's annoying. It has if condition, and then this. This. So, yeah, it's annoying at points, but it's far more consistent, which is more important to me. Honestly, if I am going to switch to V2, I'll probably just switch to Rust mainly because the syntax is just so nice, but the portable exes are also baller, absolutely. The fact that you can, just have the exe, in Rust, by the way, I'm talking about Rust, you can just compile and just give the exe and here you go. That's it. If you don't use text files for storing data or whatever, you can just give the executable to someone and they can execute it. And that is very nice. In C#, it's quite a bit more annoying. Yes, because I'm trans. Where was I? Yeah, so Rust has that, don't worry. Knowing the niche commands in Bash is just knowing how to exploit bugs in commands, yeah. And that shouldn't be a thing in language. You shouldn't have to use bugs to be good at a language. I don't know if I agree. Python is fairly consistent to me. Maybe, I haven't tried it to an extent where that would matter, to be fair, but by the rumors, pretty much, of what I've heard, it's not a thing that I want to get deep into. When with Rust, yeah, I can pretty confidently say that I want to get deep into it. Yeah. You don't fuck around. No transphobia on this stream. Right. Where were we? We need a way, right, in all programming language. However, the second part is different. In languages with a garbage collector, the garbage collector keeps track of and cleans up memory that isn't being used anymore, and we don't need to think about it. In most languages without a garbage collector, it's our responsibility to identify when memory is no longer being used and to call code to explicitly free it. Just as we did to request it. Doing this correctly has historically been a difficult programming problem, true. If we forget, we'll waste memory. If we do it too early, we'll have an invalid variable. If we do it twice, that's a bug too. Fuck. We need a pair exactly one allocate with exactly one free. That sounds fucking exhausting. If I touched C and like used it, I would probably get used to it and be fine about it, but god, that still sounds exhausting. Rust takes a different path. The memory is automatically returned once the variable that owns it goes out of scope. Here's a version of our scope example from there using a string instead of a string literal. Yeah, so similar, very similar. And this is my point on making a block of your own, to maybe do this explicitly. Because in garbage collected languages, it's only being done for us like eventually. But in something like Rust, and I feel like in not many things, say I make a RAM heavy operation, I put it in a block, and once this small block is over, everything there is cleaned at this moment. Instead of waiting, instead of waiting for the entire function to finish doing its thing, and only then freeing. So you can choose when to clear memory, which is incredible. Not sure how useful that actually is. But sounds like very nice, because you're putting you're almost like evading a responsibility if you want to, but if you don't want to, you can use it to your advantage. And that sounds incredible. It's not something I've seen in other languages, or at least this explicitly. There is a natural point at which we can return the memory a string needs to the allocator when S goes out of scope. When a variable goes out of scope, Rust calls a special function for us. This function is called drop, and it's where the author of string can put the code to return the memory. Rust calls drop automatically at the closing curly bracket. So imagine you can implement your own drops and so on. You don't really have any more control, but it makes it so much easier. Really? Well, hold up. So, like in a garbage collected language, what would happen is you call some function, say it's main, and the entire scope of that function is just that. So the garbage collector is a secondary process to your main process that runs and consistently checks whether the memory is being used too much. And when it is, it cleans it. But in Rust, what I imagine happens is memory is cleaned on every closing bracket. So you can decide when you want to clear your RAM. So I guess, yeah, like it is like much easier, but I think it also gives me more control too. In C++, this pattern of deallocating resources at the end of an item's lifetime is sometimes called resource acquisition, is initialization. The drop function in Rust will be familiar to you if you've used RAI patterns. I haven't, I don't think. This pattern has a profound impact on the way Rust code is written. It may seem simple right now, but the behavior of code can be unexpected in more complicated situations when you want to have multiple variables use the data we've allocated on the heap. That is true. Let's explore some of those situations right now. You could technically split code into functions. I mean, yeah, but that's when it comes into. There are some things in programming that you can possibly do to make something better, but it's just not worth it, which is the reason why you don't do it. Yeah. And even then, like, even if you do split it into a separate function, you have no guarantee that it will actually be cleared, because it's up to the garbage collector to do that. Yeah, I think that's the case. But in Rust, I imagine it's done on every closing bracket, making your programs use far less memory because it's cleared immediately. I'm probably assuming too much though. By the way, I love streaming so much. It's like so fun. I even got my first ban today, like holy shit. Didn't expect it would be so quick, but yeah, this is fun, like learning Rust, talking with you guys, that's great. Makes my like mood go up. Been typing this entire time, not a wow, holy shit, that's a really huge improvement at such a short time period. Good job. Fuck yeah. I know, right? Like, goddamn, toast be toasting. We can probably guess what this is doing. Bind the value 5 to x, then make a copy of the, I imagine that's not what actually is happening, of the value in x and bind it to y. We now have two variables, x and y, and both equal 5. Oh, this is indeed what is happening, because integers are simple values with a known fixed size, and these two 5 values are pushed onto the stack. Interesting. Now let's look at the string version. The string version. Using your nickname as an actual word to, like, to mean something can often be a really fun joke. Finally, faster at touch typing than my usual typing. Let's go. Fuck yeah. That's such a big, like, I guess stepping stone. Because now there's no reason for you to not touch type. Fuck yeah, good job. Really glad that you picked it up. This looks very similar, so you might assume that the way it works would be the same. It doesn't. That is, the second line would make a copy of the value in S1 and bind it to S2. But this isn't quite what happens. Take a look at figure 4.1 to see what is happening to string under the covers. A string is made up of 3 parts, shown on the left. So, what are those parts? We have name, which is the actual value, pointer that points to the place in the heap, I imagine, length, meaning length, the current one, and capacity, so how much it can even have inside of it. I see. A pointer to the memory that holds the contents of the string, a length and a capacity. This group of data is stored on the stack. On the right is the memory in the heap that holds the contents. The length is how much memory in bytes the contents of the string are currently using. The capacity is the total amount of memory in bytes that the string has received from the allocator. The difference between length and capacity matters, but not in this context, so for now it's fine to ignore the capacity. When we assign S1 to S2, the string data is copied, meaning we copy the pointer, the length, and the capacity that are on the stack. We do not copy the data on the heap that the pointer refers to. In other words, the data representation in memory looks like figure 4.2. It's exactly what I expect this to work. The fact that complex types are stored on the heap. But it seems like Rust is more explicit about how that works. I've been confused over and over again in C# and what are the actual rules. I guess I've never really read the book on a programming language, and that's the reason why I'm so constantly surprised. But regardless, you never really learn a language where the way you do it is by reading a book, or at least for me that was never the case. So this is very refreshing. The representation does not look like figure 4.3, which makes a shallow, I think, copy, which is what memory would look like if Rust instead copied the heap data as well. If Rust did this, the operation S2 equals S1 could be very expensive in terms of runtime performance if the data on the heap were large. Earlier, we said that when a variable goes out of scope, Rust automatically calls the drop function and cleans up the heap memory for that variable. But figure 4.2 shows both data pointers pointing to the same location. This is often the problem with garbage collection. This is a problem, as I said, when S2 and S1 go out of scope, they will both try to free the same memory. This is known as a double free error, and is one of the memory safety bugs we mentioned previously. Freeing memory twice can lead to memory corruption, which can potentially lead to security vulnerabilities. Yeah, me neither. Never read a bug on a programming language. Yeah, the lag is bad, unfortunately, but my first ever stream was with a lower latency, and everything else was just so laggy, like incredibly. Even now, when I try to type something in, it's still not as fast as when I'm not streaming. So it's already like not perfect. But with the better setting, it's just pretty much impossible to do anything. So that's the reason why I picked this setting instead. So same. The Rust book is the first book that I'm reading on the programming language. I always thought that, oh come on, really? You read a book on a programming language? Come on. Like, isn't it like... you're learning tech. Why are you touching paper? That's my thought, I guess. But this book so far has been written incredibly well. Like, wow. Yeah. Hands-on stuff. Hands-on like the book. I usually when I learn something new, I just try to make the thing and then learn what I have to learn. But Rust deserves a more foundational knowledge. How would you create a shallow copy of a string though? We'll get to it, I can only imagine. We'll probably get to it. To ensure memory safety, after the line of this, Rust considers S1 as no longer valid. That's exactly what I thought. Therefore, Rust doesn't need to free anything when S1 goes out of scope. Check out what happens when you try to use S1 after S2 is created. It won't work. You'll get an error like this because Rust prevents you from using the invalidated reference. Borrow of moved value. Move occurs because S1 has the type string, which does not implement the copy trait. Interesting. And I guess stuff that has the copy trait is copied automatically. Okay. This error originates in the macro, whatever, which comes from the expansion of the macro print line. Interesting. Consider cloning the value if the performance cost is acceptable. That is so interesting to be as a compiler error message. Like, basically giving the idea of what is a reasonable thing to do. Oh, I'm so sorry. My mic is pretty damn close to me, so I might accidentally touch it sometimes. If you've heard the terms shallow copy, I have, and deep copy while working with other languages, the concept of copying the pointer, length, and capacity without copying the data probably sounds like making a shallow copy. Yeah, the names of them are very confusing. Base? Or do you mean boss? Or whatever, however it's pronounced. Like the fish. Oh, sorry. Yeah. But because Rust also invalidates the first variable, instead of being called a shallow copy, it's known as a move. In this example, we would say that S1 was moved into S2. So what actually happens is shown in figure 4.4. Interesting. That solves our problem. With only S2 valid, when it goes out of scope, it alone will free the memory, and we're done. Oh, so it's is shallow. I got it backwards. Yeah, so shallow copy is like the bad copy. The deep one like re-adds the same exact thing onto the heap again. Fun fact, AutoHotkey doesn't have a way to make a deep copy by default. You have to implement it. Good luck doing that in V1. That's all. Oh, alright. In addition, there's a design choice that's implied by this. Rust will never automatically create deep copies of your data. Therefore, only automatic copying can be assumed to be inexpensive in terms of runtime performance. Variables and data interacting with clone. If we do want to deeply copy the heap data of the string, not just the stack data, we can use a common method called clone. We'll discuss this method syntax. God damn, my throat is so dry. Trait is kind of like a set of functions that is associated with struct or something. Oh, so kind of like an interface. All you boys doing sports. Yes, so not just the stack data, we can use a common method called clone. So now that's very simple. Surprisingly so. We'll discuss method syntax in chapter 5, but because methods are a common feature in many programming languages, you've probably seen them before. Yeah, here's an example of the clone method in action. Like, that's simpler than it usually is in other languages. Just clone, and that's it. This stream alone makes me realize how important the good mic is. Yeah. I remember when I didn't have the mic holder. When I listen to my older videos, the difference is huge. Like, take my latest video and like 7 videos ago, you'll clearly see like a big difference, and that's just the mic stand. And then also having a good mic matters incredibly. This works just fine and explicitly produces the behavior shown in figure 4.3, or the heap data does get copied. When you see a call to clone, you know that some arbitrary code is being executed, and that code may be expensive. It's just a visual indicator that something different is going on. Yeah, I like that. Stack only data copy. There's another wrinkle we haven't talked about yet. This code using integers, part of which was shown in listic 4.2, works and is valid. ASMR when I feel like it. I'm a very slutty girl. So I might just whip out ASMR out of nowhere. You'll never expect it. Yes, I am suggesting that ASMR is slutty. It often is. Like, there's no way that people argue that, oh, actually mouth sounds are completely not sexual. They just sound very nice. No, I severely disagree. You don't have to be like rock hard when you listen to mouth sounds ASMR, but I think it's implied that it is sexual, but like nothing bad about that. Unless it's me that's that horny, but I just find it hard to believe that mouth sounds are like entirely non-sexual. No. There's another wrinkle we haven't talked about yet. Yes, so this is valid, but the code seems to contradict what we just learned. Not really, because these are in the stack, I imagine, right? We don't have to call to clone, but X is still valid and wasn't moved into Y. Oh, it's an implicit clone because it's on the stack. That's interesting. The reason is that types such as integers that have a known size at the compile time are stored entirely on the stack, so copies of the actual values are quick to make. That means there is no reason we would want to prevent X from being valid after we create the variable Y. In other words, there is no difference between deep and shallow copying here, so copying clone wouldn't do anything different from the usual shallow copying, so we can leave it out. That's a very reasonable reason. That's in another pin. You're so right, because it's so me to just go on a tangent like this. It's so me. I'll say the weirdest shit. Out of nowhere, too. Like, I imagine people watching my videos, especially the earlier ones, the way I portray myself there and on stream is very different. Because whatever goes into my head, I just say. I mean, almost. Thankfully, like, I don't get random urges to say slurs or some other horrible shit, so I'm pretty much safe. But there will be a point at which I'll say some very controversial take with which people will disagree with. And I probably have already. But that's what streaming is, I guess. Yeah. Rust has a special annotation called the copy trait that you can place on types that are stored on the stack as integers are. We'll talk more about traits in chapter 10. If a type implements the copy trait, variables that use it do not move. but rather are trivially copied, making them still valid after assignment to another variable. Yeah, that makes incredible sense. Rust won't let us annotate a type with copy if the type, or any of its parts, has implemented the drop trait. So traits are pretty much interfaces, or at least the idea behind them. That's easier to understand. If the type needs something special to happen when the value goes out of scope, and we add the copy annotation to that type, we'll get a compile time error. To learn about how to add the copy annotation to your type to implement the trait, see derivable traits in Appendix C. Cool, we'll learn that eventually. That's cool. So, what types implement the copy trait? You can check the documentation for the given type to be sure, but as a general rule, any group of simple scalar values can implement copy, and nothing that requires allocation or is some form of resource. Jesus, that's a hard sentence to read. And nothing that requires allocation or is some form of resource can implement copy. Jesus, what a sentence. Here are some of the types that implement copy. All the integer types, naturally. The Boolean type, imagine if it was stored on the heap, it would be funny and unnecessary. All the floating point numbers, the character type, and tuples. What? If they only contain types that also implement copy. Interesting. So tuples pretty much inherit the trait if all the values in that tuple do have that trait. That's so smart and reasonable. Oh my god. It's so nice to be learning a language that you continue learning and you're like, oh my god, that makes so much sense. I kind of expected at least some of the opposite. So far I'm like, all the decisions that I'm seeing in the Rust language, I'm way more positive about it than I expected. I already expected myself to go absolutely fucking crazy about it. Ownership and functions. The mechanics of passing a value to a function are similar to those when assigning a value to a variable. Passing a variable to a function will move or copy, just as assignment does. As an example of some annotations, showing where variables go into and out of scope. So we start by making an actual string, it comes into scope. We pass it into a function, and it moves into the function. So it's no longer valid here. Yeah, like at all. It stops being valid, we can't use s again. That will be interesting to learn when we go to borrowing. Yeah, that's, I imagine, exactly the thing. I mean, to be fair, the Rust Foundation has recently made a horrible decision, and there was like a whole controversy about it. So it is still a corporation, just maybe not as big of a one. But yeah, just many very reasonable decisions. When with other languages, you go through it and you're like, oh god damn it, really? Why can't you? Like, wow, what a terrible sound. Like in C#, for example, to check if a string is empty or null, guess what you do? You do string dot is empty or null. Use this method and pass the string into it, instead of something like string equals or is null or equals to like empty string. Like, why is that a method? C# has these decisions from time to time, and I don't like them because, like, why? You could easily, I'm sure, make the syntax sugar for it, but you just decided not to because it doesn't really matter. Fuck you! It does to me. Nah. And Rust so far, I mean, shouldn't I also have the same kind of complaints about string double colon from? Technically I should, right? But here it makes sense. Like, yes, we're creating a new type of this type, so that's why this syntax makes a lot of sense to me. There is no sense to be having a method to check for is it null or empty. It should, by all accounts, like, be able to compare with something like the is keyword. So that's why I'm angry at C# but not at Rust. Right, so x comes into scope. X would move into the function, but the integer has the copy trait, so it's okay to still use x afterward. Oh, But that's interesting. Here x goes out of scope first, then s. I imagine because s is on the heap, but because s value is moved, nothing special happens, meaning x goes out of scope and is cleaned from the stack, but s already moved to the function, meaning it already cleaned itself up by returning out of that function. I love this. I love this so much. It makes so much sense. And yeah, some string comes into scope. Here some string goes out of scope and wrap is called. Here some integer goes out of scope. Nothing special happens. That's good to know. So my previous example, where we make a block here and make a variable here, no, it's still valid actually. It's so I thought what is the case is that making a block to make it call the drop method does not work. Actually, no, it still works like I think it does. Just if I pass a stacked variable into something, I can still use it until the end of that block. So my idea still holds up, but Rust is more lenient than I thought, basically. If we try to use s after the call to takes ownership, Rust would throw a compile time error. These static checks protect us from mistakes. Try adding code to main that uses s and x to see where you can use them and where the ownership rules prevent you from doing so. I love when languages top me rather than bottom, rather than being the bottom. I like when languages are strict with me and like are no bullshit. Alright, gonna take a bathroom break and come back very quickly. I should make a hotkey for this. got overly excited because I thought hot water returned. Currently my house doesn't have hot water, so I have to like boil stuff to take a shower or something, so no, it's still gone. And it's going to be for approximately 10 days. How I'm going to survive, I don't know. Oh my god, I love this so much. Wait, what? Huh, that's actually kind of surprising that it exists. That's so cute. That's exactly what I want, actually. The streamer gone idea I actually just straight up stole from Slimesicle, a streamer that I like very much. So when he needs to leave, he basically makes this entire joke that, okay Chad, I'm gonna leave, not for a while, I'm gonna return, don't freak out. And I basically love that because it's so cute. Okay. Return values and scope. Returning values can also transfer ownership. Oh. Oh, right, yeah, obviously. Shows an example of a function that returns some value with similar annotations as those in listing for 3. So we call a function that returns a variable. Now it's in S1. S2 comes into scope. S2 is moved into another function, which also moves its return value into the S3. Here, S3 goes out of scope and is dropped. S2 was moved, so nothing happens. S1 goes out of scope and is dropped. Так. Gives ownership. More importantly, takes in, gives back. A string is returned and moves out to the calling function. What about S2? Oh, it continues moving. It's not dropped because it's moved rather than dropped and recreated. Yeah. Oh, wow. That's so smart. How long have I been streaming for? 2.5 hours. I think... I wonder if he ever will notice me or other my streams. So I think I'm a bit better at using my voice today than I was yesterday, where I can still continue on, which is a bit better than the last time. The ownership of a variable follows the same pattern every time. Assigning a value to another variable moves it. When a variable that includes data on the heap goes out of scope, the value will be cleaned up by the drop unless ownership of the data has been moved to another variable. While this works, taking ownership and then returning ownership with every function is a bit tedious. Yeah, I imagine so. What if we want to let a function use a value but not take ownership? It's quite annoying that anything we pass in also needs to be passed back if we want to use it again. In addition to any data resulting from the body of the function, we might want to return as well. Good point. Rust does let us return multiple values when using a tuple. Yeah, but then you have to destructure it. Which I guess you would do anyway, but it's not the real solution, at least not always, definitely not. But this is too much ceremony and a lot of work for a concept that should be common. Luckily for us, Rust had a feature for using a value without transferring ownership called references. Ooh. Okay, so far I understand ownership. I want to know when I won't. Or maybe I'm a genius. Or maybe I'm just like qualified, I guess, to learn Rust. If I just end up understanding it pretty easily. Someone on the street is just screaming their eyes out for some reason. A reference to a string value. A reference is like a pointer. Oh, right. Yeah, fuck, that's so nice. is like a pointer in that it's an address we can follow to access the data stored in that address. That data is owned by some other variable. Unlike a pointer, a reference is guaranteed to point to a valid value of a particular type for the life of that reference. Here's how you would define and use a calculate length function that has a reference to an object as a parameter instead of taking ownership of the value. Okay, so we have this main that gets a string s1 and gets its length by passing the reference to it. And now, as you can see, we don't need to type return s.length because the last expression is automatically returned in a Rust function. And it returns a usize. That's interesting. Usize. Usize is different depending on your architecture. I read this. So if you use a 32-bit system, usize will be a maximum of 32 bytes, I think? Bits? No. But if you use a 64-bit system, it will be 64 instead. Because of this inconsistency, if you can, make the type explicit. But imagine the length variable, technically it's a variable, method automatically returns this type, which is why we return usize. I know, right? It's like, huh. It's interesting. So yeah, we let it borrow it. And yeah, that's it. Very simple. First, notice that all the tuple code in the variable declaration and the function return value is gone. Second, note that we pass SL into calculate length, and in its definition we take string rather than string. So with the ampersand symbol, meaning we take a reference. That's also nice that you are explicit about that. Those ampersands represent references, and they allow you to refer to some value without taking ownership of it. So we have S for the string, has the value, and that's it, because it's on the stack. Now, a pointer to it, which is S1, a different thing, right? Oh, S is the thing that we passed into the function, which has the pointer to S1, which has a pointer to the heap. I've never seen something like this be explained this well. Who the fuck wrote this book? And why is it so good? I get why it's called the Bible now. This is so interesting. Is getting into C territory, which is even more interesting. I like the ampersand before variables for its pointer. Yeah. It makes sense, and it gives use to the ampersand symbol. Oh wait, I forgot about and. I was thinking of Vim, where ampersand pretty much is useless compared to almost every other character that is useful. So that's why I thought ampersand is useless. Let's take a closer look at the function call here. The S1 syntax let us create a reference that refers to the value of S1 but does not own it. Because it does not own it, the value it points to will not be dropped when the reference stops being used. Likewise, the signature of the function uses ampersand to indicate that the type of the parameter S is a reference. So our reference is a specific type, or I guess subtype. I guess they would be right, huh? Let's add some explanatory annotations. Those are called comments, bro. S is a reference to a string. Here, S goes out of scope, but because it does not have ownership of what it refers to, it is not dropped. The scope in which the variable S is valid is the same as any function parameter scope. But the value pointed to by the reference is not dropped when S stops being used, because S doesn't have ownership. When functions have references as parameters instead of actual values, we won't need to return the values in order to give back ownership, because we never had ownership. So something that I feel like is a trap is for you to just go in and use references pretty much always. I imagine that is exactly the thing that you shouldn't be doing, and try your best to transfer ownership, and only when it really doesn't make sense to use references. Basically, this could be an anti-pattern for Rust specifically, or at least that's what I'm guessing. We call the action of creating a reference borrowing, as in real life, if a person owns something, you can borrow it from them. When you're done, you have to give it back. You don't own it. So what happens if we try to modify something we're borrowing? I imagine you can't still, right? Try the code in listing. Spoiler alert, it doesn't work. So yeah, we borrow it, but yeah, we can't change it. It's still immutable. Oh, it's not about immutability. Or is it? No, it's immutable, right? Let's check. Cannot borrow this string as mutable as it is behind a reference. Yeah, you still have to explicitly say something is mutable for it to be mutable. That is so nice. You have the guarantee that your data will be correct, pretty much. Just as variables are immutable by default, so are references. We're not allowed to modify something we have a reference to. Mutable references. We can fix the code from listing 4.6 to allow us to modify a borrowed type, a borrowed value, rather, with just a few small tweaks that use instead a mutable reference. I can now see why people don't like the syntax of Rust. It's quite bloated, or so you would think, but for the architecture of the language, it makes sense. I don't like that type annotations go after the variable. I like them more when they are before the variable. Like, to me, the first information I want to know is the type of the variable and then its name, not the other way around. That's good. That means you're probably going to be a Rust junkie as well. And I feel like you fit the role incredibly because of how you approach programming. Yeah, I feel like Rust is the perfect language for you. And also for me, but for slightly different reasons. Very similar though, still. First, we change S to be mutt. Mutt. I want to say it like mutt instead of mute because it will probably annoy some people. Then we create a mutable reference with mutt s, where we call the change function. And update the function signature to accept a mutable reference with some string mutt string. This makes it very clear that the change function will mutate the value it borrows. Now that is amazing because in even something like C#, you kinda don't know and you have to constantly check, when in Rust it is explicitly stated to you, this mutates your data. Be knowledgeable of that fact. And that's so nice because that means that IntelliSense will have to tell you that because it's in the language. You won't have to rely on unreliable comments. Just, I love that. Mutable references have one big restriction. If you have a mutable reference to a value, you can have no other references to that value. What? This code that attempts to create two mutable references to S will fail. Yeah, I see. So only one owner at a time. Or one borrower. Yes, I like that. That way, you know for sure that your data is being modified correctly, rather than it being modified at different times and doing weird shit with it. As mutable, it says. Can borrow as mutable. So as immutable, it maybe can. I guess that's going to be explained. This error says that this code is invalid because we cannot borrow S as mutable more than once at a time. The first mutable borrow is an error 1 and must last until it's used in the print line. But between the creation of that mutable reference and its usage, we try to create another mutable reference in R2 that borrows the same data as error 1. So naturally, we can just move this line after the print line, if that was what we are doing. But in this case, they don't even need to be mutable, or this. But yeah, once again, just example. The restriction preventing multiple mutable references to the same data at the same time allows for mutation, but in a very controlled fashion. It's something that newer stations struggle with because most languages let you mutate whenever you'd like. I feel like I'm also going to struggle with it, but I don't think I'm gonna blame the language for doing it this way. Rather, I'll like basically learn to use it to my advantage. Because the language making you do some things is also a guarantee that it does, you know? The benefit of having this restriction is that Rust can prevent data races at compile time. A data race is similar to a race condition and happens when these three behaviors occur. Two or more pointers access the same data at the same time. At least one of the pointers is being used to write to the data. There is no mechanism being used to synchronize access to the data. Data races can cause undefined behavior and can be difficult to diagnose and fix when you're trying to track them down at runtime. Rust prevents this problem by refusing to compile code with data races. I love this shit. So you had this problem, right? Have a bigger problem now. That sounds like a non-solution, but it is actually a solution because it will force you to write better code that doesn't have that problem to begin with, rather than discovering that problem later where you might have a more complex structure that is more difficult to debug than when you're creating the code to begin with. As always, we can use curly brackets to create a new scope. Interesting. Yes, the Rust way. Reading the Bible stream, non-religious, trust me. Rust is very religious. Yes, to create a new scope, allowing for multiple mutable references, just not simultaneous ones. Yeah. R1 won't be accessible here, which is why this is okay. Rust enforces a similar rule for combining mutable and immutable references. I am noticing I am hungry. Almost 3 hours. Okay, let's save. Oh, I'm so sorry. Let's finish reading this, and after that, I'll be ending stream. So where were we? Yes, Rust enforces a similar rule for combining mutable and immutable references. This code results in an error. Because they are not mutable. I see. Not quite. We're gonna finish reading this section, and after that, yes. Because I'm hungry. Because I'm hungry. Big problem. Here's the error. Can I borrow S as mutable? Because it was also borrowed as a mutable. That's interesting. So that's the issue. Huh. We also cannot have immutable references while we have an immutable one to the same value. Hold up. Oh. Holy shit, I didn't recognize it. So even though this variable S is mutable itself, when we pass a reference to it, it's still immutable by default. Even though the variable itself is mutable, we can still make sure that it's immutable unless we explicitly state that it should be. Holy shit. Wow. What? Holy shit. That's what? That's so good. Wow. Users of an immutable reference don't expect the value to suddenly change out from under them. However, multiple immutable references are allowed because no one who is just reading the data has the ability to affect anyone else's reading of the data. Makes sense. Note that the reference's scope starts from where it is introduced and continues through the last time the reference is used. For instance, same thing. This code will compile because the last usage of the immutable references, the print line occurs before the mutable reference is introduced. So we have the unimmutable reference of immutable S. We use them both, and then we create a mutable one because we used them already. Yeah, meaning we moved them into the function and they get dropped there. I'm probably gonna eat my words later, but I think that if you find all of this, at least so far, difficult to figure out, it's more so an experience like lack, I guess. I think I've been programming enough where this is pretty like obvious and understandable to me, where a more beginner programmer might struggle with this because of the lack of experience. Because I expected to struggle already on understanding all this, but that's not yet the case. I'll probably eat my words though, soon enough. These scopes don't overlap, so this code is allowed. The compiler can tell that the reference is no longer being used at a point before the end of the scope. Oh, it can also do that. Oh, yes, shadowing works exactly like that. Even though borrowing errors may be frustrating at first, remember that it's the Rust compiler pointing out the potential bug early, at compile time rather than at runtime, and showing you exactly where the problem is. Then you don't have to track down why your data isn't what you thought it was. 10 p.m. for me, and I need to do some work, so I gotta go. Math exam went great, by the way. That's amazing! Good job! Alright, well, I need to go too. I would go on for further, but I'm just hungry. Very hungry. Let's go to... Oh. I'm so used to my previous hotkeys. I still think that it's a good idea to change them, though. Okay, I update the link. And that's it, I guess. Thank you for sticking with me and learning Rust with me. And we're going to be doing that again and again and again until we learn Rust. And at that point, we'll be making stuff in Rust, rewriting my whole entire project until I move to Linux. And then probably more Rust again. So, see ya! Goodbye! Glad you were there.